the previous two lectures, I have been talking to you about the effects of observing motion when you see it from a rotating frame. To demonstrate this, in this lecture I am going to do some experiments and show you precisely what happens, and you will see that whatever I have talked about earlier does happen. So, for that I have this simple device. You see earlier what we have said is you see this effect on the earth also, but earth's rotation is very small and you see those effects only when things are fired over a long range. So, what we are trying to do now is make a simple device where we can observe this effect of seeing things in a rotating frame. So, what I have here is a platform which can be rotated. I made the x and y axis with this red tape out here, and if I rotate it, you see in the picture that you see the axis rotating, right. So, this is the axis rotating, and if I now make things move here, they move pretty much in a straight line. It is as if I am observing the motion from outside space on the earth. So, let me show this to you a couple of times more. So, here is something which is going, and it is going pretty much in a straight line, and you see the axis rotating. On the other hand, if I want to observe the motion in the rotating frame, so to see that, what we have done is we made a platform here on which I can mount a camera. It could be as simple as your mobile. For example, if I can put my mobile camera here and put the video on, you will see that what this camera records is what is seen in a rotating frame. The first effect of observing things in rotating frame is going to be that you are not going to see these axes moving. So, let me show that to you. So, I am going to mount this camera here on the rotating platform, and now rotate the platform, and I will show you juxtapose the rotation of the platform taking from stationary camera outside and a picture which is taken from the video camera on the mobile. And you will see that when I flash you the video camera picture which is mounted on this rotating platform, you will see these axes not rotating. So, let us do that. You see right now I am showing you what is seen from the camera outside, and now I am going to show you what is seen from this video camera on the rotating platform, and you see that axes are not moving in this frame. So, what I am going to do now is rotate this platform, and what you see on your screen is this rotating platform being observed from a camera on that platform itself, and therefore, you see these red lines which show the axis, if you like, stationary. On the other hand, you see lights overhead as moving. That is because the camera is now on this rotating frame, rotating platform, and therefore, whatever we see is things being observed from the rotating frame. Just to convince you that this is a camera taking picture from the rotating frame, I will remove my camera and show the same platform now from the camera outside, and you see now the lines rotating. So, what I am showing you now is a shot of this platform stationary from the camera that I am going to use on the platform. You see the lights overhead are also stationary, that means the platform is stationary. Let me now rotate the platform, and you see that those red lines which denote the axis are also rotating. Lights are still stationary, the reflection of light is still stationary, and that means the camera is outside the platform. It is like observing the earth from outer space. Now, what I am going to do is put this camera on the platform, and as I do that, you will see that the lines become stationary and the lights start moving. So, now I am observing these lines sitting on the rotating platform, and therefore, these lines have become stationary because I am sitting on that platform, whereas the overhead lights are moving. So, it is as things are being observed from a rotating frame. In this demo, what I am going to show you what we saw theoretically in the previous lecture, in that when you observe a particle or an object moving in a rotating platform, sitting in that platform and sitting in that frame, you will see it getting curved because of the path becoming curved because of the Coriolis and the centrifugal force. So, let me just show you this stationary platform first, and if I roll a ball on this, you see it goes straight. I mean, it is getting curved right now because there is some slope, but if I move it fast enough, you will see a heavier ball, it would not really deviate from much from its path. It goes quite straight. So, what I am showing you is that when the platform is stationary, the ball is moving pretty much in a straight path. Now, I will give the platform a rotation and move the ball, and you will see still it is going in a straight path. Although platform is rotating, the ball seen from the outside inertial frame is still moving in a straight path. Let me show it to you again. You see it is gone in a straight path. How does it look from the moving camera or the camera which is rotating with the platform? And that picture you are going to see when I show you the video taken from mobile camera mounted on rotating platform. And now let us take pictures of different motions of these balls with different initial conditions. So, let me do that. Sometimes I will throw the ball towards the center, sometimes I will throw the ball away from the center, and you will see different conditions. Motion is quite different. Let me move it a little faster. I will throw it towards the center and see what happens, towards the center again and see what happens. Now, I will move it away from the center. So, here we go, and you see it getting curved when it is seen from the camera mounted on the rotating platform itself. Now, let me show you that the sense of curvature is different when the platform is rotated the other way. Now, I am showing it rotating it the other way, and let us see, now the sense of rotation is going to be different. So, depending on which way is omega, the Coriolis and Coriolis force changes direction, centrifugal force is always towards outside. So, just keep watching it, and you see the sense of rotation has changed. I will again go away from the center, and I will now move towards the center. Let me show this in slow motion again to see it very clearly. A superb demonstration of the effect of rotation or observing rotation of a frame is that if you have a pendulum on that platform, its plane of rotation starts moving. So, let me show that to you. What I have done here is a pendulum here that is being shown on the camera, stationary camera outside. I am also going to picture it through a camera mounted on the platform itself, and you will see that when the platform rotates and observed from this rotating frame, that is from the camera mounted on this platform, you are going to see that the plane of the pendulum starts rotating. And I will showing the rotation of the plane of the pendulum. Then when I stop the platform, you will see that actually plane of the oscillation of pendulum has not rotated. It is the effect of seeing it from the rotating frame. So, let me start this pendulum, and you will see it is moving perpendicular to this red line, and now I will start rotating the platform. And what you notice is, then I am going to show you the video taken from the platform mounted camera, and you will see that the plane of this pendulum will look like it is rotating. Actually, that is, as I said earlier, the effect of watching it from a rotating platform. and I will show you that plane actually in the outer space or the inertial frame has not moved, because if I stop this right where I started from, you see the pendulum is still rotating perpendicular to that line, and you can see that the orientation is the same as the starting one by looking at the positions of the light. Let me now show that the rotation of the plane is going to be opposite if the rotating platform moves in the opposite direction. So, let me again oscillate this pendulum and move the pendulum in the opposite direction, and you now see when I show you the video taken from the camera mounted on the platform that the sense of rotation of the plane of the pendulum is opposite. Again, from an inertial frame, the plane actually has not rotated, as I will show you by stopping the platform and in the same orientation as we started with, and you see again that it is actually oscillating perpendicular to that line. And finally, you can also do other experiments, one which I have not tried, but you can, if you make such a demonstration, you can try it at home, and that is to put a liquid filled jar on this from which water is leaking towards the bottom. You can make a hole underneath and let that water be collected somewhere, in a tub or something right there, and as you rotate it and film it, you will see some sort of a storm being built in that water which is going down through the hole. So, you will see it whirling around as if there is a storm, those that you see in the ocean. So, you see what I have shown you is a very simple demonstration to make at home, to make it in your college, to make it at your institute, to make in classroom. All it requires is a ball bearing on which you fix this platform. It could be a rectangular shape, and put a rod here and put a platform on top on which you can put a camera. Now, the cameras and video cameras is readily available, your mobile is one. So, it is a very easy demonstration to make, and with this the effects are seen very clearly. It becomes like your rotating earth or any rotating platform or rotating frame.